everyone, my name is Sheng Yang, a postdoc working with Professor Jesper Solomon at Stockholm University. Today I am very honored to have the chance to present our recent work on HAFFET. It is an open source Python package that can be used to help fit and analyze the photometric and spectroscopic data of transients. It's now publicly available, so you can easily find it online in the ReaderDoc, GitHub, pip, or AstroPH page. First, I'd like to explain why we propose this tool and why it's useful for the community. At the very beginning, our plan is to study a sample of 1b and 1c supernovae that were discovered by the ZTF and classified by the Bright Transient Survey. We find that for different supernovae, there are different fitting options. For example, the timescale of their light curves are different. For one supernova, the radioactive peak may range from -20 to 6 days relative to peak, while for one another, the light curve range may be much shorter. As a result, the data fitting should be applied in different ranges. It is possible to make some AI to automatically decide fitting options. And another clever approach is to enable user deciding options with some interactive tools. For this purpose, we designed HAFFET that for a large sample of transients, users can first run everything with the default settings. The fitting results can be called, visualized, and refitted by users in the GUI. Here is an example of the GUI showing different model fittings for one ZTF supernova. Then I want to describe in short what HAFFET can do. Here is the working flowchart. As shown, there are two classes, namely supernova list and the supernova object available in HAFFET. They are in the blue boxes here in the plot. The SNE list is to deal with the list of objects, and for each of them, an SN object class is assigned. For one object, HAFFET provides functions for users to get meta and observe data from different open public line data services like the ZTF fast photometry service. For the photometric data, HAFFET can be used to interpolate them via either some analytic model fittings or the Gaussian process regression, based on which HAFFET can then estimate the bolometric light curves via either the blackbody phase or some analytic bolometric correction functions. The bolometric light curves can be afterwards fitted with either some built-in models, for instance the famous net model, or some user-defined analytic models. In the meanwhile, HAFFET can be also used to fit the emission and absorption lines in the spectra. All the fitting parameters were handled by the SNE list class that can be populated into parameter space for a simple study. I'd like to mention that besides the number of built-in models, we provide a possibility for users to add their own models or import models from external Python packages like MOSFET, Redback, etc. As you can see here, there is an example showing the magnetar fitting on the very famous superluminous supernova 2015 BN. Finally, it's worth to say that HAFFET is still in a beta version. There are a lot of functions need to be implemented. There are a lot of bugs need to be fixed, and I hope I can try maintain it as long as I can. And I would be very happy if it's helpful for some of your projects. And please let me know if there are any questions, and I'm always happy to help. Thank you.